Okay, I think this is probably new for you guys. All right, here's what I want you to do on this worksheet. I'd like you to graph each of these, just a rough sketch, just for practice, because that's what we've been doing in this unit. Okay, I'm going to throw some other functions in here that we've studied in the past too. For example, number 1, this top equation, we're going to find the solution that is the coordinates where these cross. Okay, the solutions, it'll be plural in most cases. So right here, I have 3x minus y equals negative 2. The way I'd go about graphing that is I'd probably change it to slope-intercept form. I guess I could do it over here. Let's see if we can just do that real quickly. We've got y equals 3x plus 2. Got that? Kind of moving some things around here and there. Slope-intercept form, so I'd be up 2 for the y-intercept. The slope would be up 1, 2, 3, and over 1. Quick sketch of that line. So I've got a line, and the line is intersecting with what shape that we have been studying here?
Circle.
Which one of those, yeah. You're going to hit it eventually. It's a parabola. It is a parabola. Now, more specifically, what kind of parabola? Up, down, left, right. Okay, and now even more specific, right or left?
Right.
Oh, actually, this is not right or left, sorry. This is up, yeah. This is an x squared. I had right left on my mind because of that example I did. We have one coming that's a right left. I think it's on your worksheet. This is an opening up one. So I'm not going to be too specific here because I'm not using graphing as the method for finding the solutions. That method for nonlinear systems is probably not going to work very often in real life. Okay, but in this case it would have. You'll see in just a minute why. But quick sketch. How many solutions then do we expect? 2. Okay. So here's how we're going to do this algebraically. You have the choice algebraically of substitution or elimination. Okay, you've probably never done nonlinear systems of equations, but sometimes elimination will work with these as well. Okay. If not, go for substitution. But right here, if I wanted to, I could eliminate y. I cannot eliminate x. Do you see why? It's like the 2 different x's, 2 different powers. I could eliminate y though, right? If I rewrite this top equation as 3x minus y equals negative 2, and the second one as multiply through by negative 1, so it's negative 2x squared plus y equals 0. Put a line underneath it. Okay, all I did was take this first equation, multiply it by negative 1. I have 3x minus 2x squared equals 2. I'm just adding them up. Note that I am not combining these 2 terms. They are not like terms. Is there a negative on there? Yeah, it probably disappeared right after I wrote it. The little negatives and then the plus, you know, one portion of the plus always doesn't show. So there it is. It is a negative 2. So if I move everything over to the right, here's the quadratic equation that I have. Positive 2x squared minus 3x, and the negative 2 remains negative 2. So I'm moving everything over to the right. And this is your specialty as advanced algebra 2 students, solving quadratics, right? On the left it was negative, I've moved it over to the right. I've added it over. So, can we factor this? Can we factor this? It is factorable. Okay, I think all of them will be on your handout that I give you. But if it weren't factorable, what would you then do? Right. And you have one other method that nobody likes to mention. How did you get the quadratic formula, or your teacher get it in the first place? What did they do? The process they went through. That all algebra students just love. It's the method. You've done it in this unit today. It's number 1 on the quiz. Yes. You completed the square. Actually, your teacher probably did it to derive the quadratic formula. But it's factoring, then quadratic formula. In some cases, completing a square is easier than the quadratic formula. We may have to have that discussion someday when that comes up. I'll have to show you. Completing a square is actually easier sometimes than the quadratic formula. All right. So this would be a -2 here and a +1 there, right? So those are my factors, so you'll do that. So I have two values of x. X equals -1/2, right? -1/2 would make this first factor 0. Or x equals 2. Okay, I'm making a huge assumption that you are professional factoring students here and able to solve by factoring. I think you've done a lot of that. Factoring fiends, yes. That's why you're in this class. So this is only a part of it. How do I find the y coordinates to go with these? Plug it back in. Where do I plug it in? How come the first? That's a good advice. Yeah. So my solutions are -1/2 comma something, and the other one is 2 comma something. So if I plug -1/2 in for x here, that's -3/2 or -1.5. I add the 1.5 over. That's -2 plus 1.5 is -1/2. Then I divide by -1, I get +1/2. Okay? I'm also assuming you can do all that. Okay? As long as you can understand, you plug it in to find y. Okay? We've done a lot of that. Does it look like in my picture that is a reasonable spot? -1/2 comma 1/2?
Yes.
Yeah, even with my rough sketch, it looks reasonable. And then the other one is plug in 2 here, that's 6. Subtract that over, that's -8. Divide by -1, it's +8. Does 2/8 look like a possibility here? 2 and up 8? Even with my rough sketch, yeah. Okay, that's it. Now, in terms of solutions, you guys understand there could be no solution, one solution, 2, could there be 3 with different shapes? Possibly. 4, there could be 4 if you have like a parabola going through a circle, right? Parabola going through a circle. 4. So you need to understand that there can be lots of solutions on these. It's possible to have no solution, right?
Yep.
I could have a circle inside of a circle that we never even cross, right? Okay, number 2. It says solving using elimination. Then check with your calculator. So we're going to do that on this one. I'd set up here substitution. Okay, well, substitution or elimination. You're going to find some where it's better just to use substitution. But if I do elimination on this, let's see what happens. What could I eliminate on this one? X squared. I cannot eliminate the y's. So multiply by -1. So my new equations are x squared plus y squared equals 13, and -x squared plus y equals -7. And so I have y squared plus y equals 6. If I subtract that 6 over, y squared plus y minus 6 equals 0. And then factor y plus 3, y minus 2 equals 0. So what are my solutions? Y equals -3 or y equals +2. Okay, whatever would make each of those factors equal to 0. It's called the zero product property. So I have something comma -3 and something comma 2. Notice I didn't even graph it, right? Didn't even graph it this time. You don't need to graph it to do it, but I'm going to do it now. If I graph this, this top one would be what? Circle with a radius of about what? 3.6, okay. Square root of 13 is about 3.6. So I'll just go 1, 2, 3. 1, 2, 3. Okay, so there it is. 3.6. And then the other one, do you know what the other one is? If I rearrange this, it would be y plus 7 equals x squared. X squared equals y plus 7. So that would be a parabola, up or down, or right or left. It's an x squared, so it's up or down. X squared, so it's up or down. And it's going up, right? Because the coefficient of x squared is positive. So what's the vertex of this guy? It is 0, negative 7. Remember to take the opposite of the number paired with the y. So 0, negative 7, 5, 6, 7, negative. And then it's going to go like this. Up. Oh, okay. Now I'm looking at my picture. I noticed something here. What's going to happen when I plug in these y values? Yes, I'm going to end up with 4. So, yes, there's going to be a plus or minus involved. So let's extend this. There's what my solutions will look like. See how it's kind of nice to have the picture. You know what to expect. We're going to find out anyways when I plug in negative 3 for y. I would probably plug it in to this equation, or even better yet, this one I'm circling right here. That's a good one to plug negative 3 into. You see why? Plug negative 3 in for y. Negative 3 plus 7 is 4. X squared equals 4 has what as its solutions? 2 and negative 2. So that means with negative 3 I could have a positive 2 or a negative 2. Let's see here. Positive 2, 3. Negative 2, 3. Yeah. It's about right according to my picture. If I plug in 2 here, 2 plus 7 is 9. X squared equals 9. I have a plus or minus square root. So I'll have positive 3 or negative 3. And those are my 4 solutions there. Right. So when you try elimination on this, what are you noticing? Have you gotten that far yet? You know. I do know, right? Okay, what variable would I eliminate here? The x squared, yeah. If I try to eliminate the y, I won't be able to. So it's x squared minus y squared equals 4. This is negative x squared plus y equals 0. If I add them up, I get negative y squared plus y equals 4. If I move everything over, I have 0 equals y squared minus y plus 4. And when I go to solve that, first of all, is it factorable?
It's really helpful. I can't feel it.
It's not factorable. It's not factorable. So you'd have to use your. Well, not just. Because it's not factorable doesn't mean that's not what doesn't mean it doesn't have a solution. It's under that label, but here's how you know it doesn't have a real solution. When you go to the next step, you go to use the quadratic formula on this. It would be y equals opposite of b plus or minus square root of b squared minus 4 times a is 1, c is 4, all over 2 times 1. So we have 1 minus 16, which is a non-real solution. Okay? Non-real solution. In other words, they're 2 imaginary numbers, or complex numbers. But because of this negative under the radical, we know from algebra now that this is non-real. Now, when I go to graph it, it makes complete sense. Well, for the most part. Yeah. X squared minus y squared equals 4. That would be centered at 0. It would be x squared over 4 minus y squared over 4 equals 1. This is a hyperbola. Centered at 0. Has a hyperbola box that is a perfect square. Go 2 in each direction. There's my hyperbola box. Perfect square going 2 in each direction. Which way does it open?
I'm gonna say left and right.
Yes. Why? How do you know? Right. It's actually that it's positive as opposed to being in front, because you could have a negative term in front, but there it is. And then this one is a parabola, y equals x squared, and it's just going to open up like this. Do you see why there's no solution here? Do you see why there's no solution on that one? We got a hyperbola opening sideways, a parabola going up. Do they ever cross? Yeah. So algebraically, it makes sense now why this was a complex valued solution. They don't ever cross. What I've done is I've taken these two equations, merged them into one through the process of elimination, and that one equation has no solution, no real solution. Right? So that means they don't ever cross. So I do have a little bit for you to do, 6 problems for you to do. I would like you to graph them, even though you don't have to solve them. Some of these, it works better to use substitution on, like the first 2 on here. They're both equal to y, just set them equal to each other. I think that'll be easier. You're not going to be able to use elimination on these ones with square roots of it. Okay? You're not going to take something with a square root over it and add or subtract it. Just something without, okay? So substitution will work on those first couple.